Hey YouTube. So I didn't expect to do another video so soon, but I got asked a question about programming from somebody I follow here, and I just wanted to make a quick video in case my reply to them was not clear. Also, because I figure it's a good topic and it gets people started. So what you're looking at here on my screen is the finished program that I wrote for hopefully a new friend, Louis Rosman, who makes some really great videos on electrical repair and some great rants about life and why you should do the thing that's easy to live with instead of the thing that's easy. And I am honestly amazed that he was willing to reply to my comment and my offer for help. So if you're listening, thank you, and glad to help. With that in mind, I am looking at this video here, and I'm going to describe to you exactly what's on my screen and what's going on and why it matters. So at the very top here we have the include stdio.h. That tells the C compiler to include your standard input-output headers. Some of you already know this. Some of you are watching this and learning, so that's why I'm going so deep into this. The second line is obviously empty. We don't care about that because in C, white space doesn't really matter. It's not like Python or other languages that use white space for execution context. So anyway, third line, int main, int argc, char, star, argv, array. What that means is that the first integer value, which is a signed integer by default in most compilers, depending on your compiler setting, make sure you check that because sometimes compilers will have the settings of int equals unsigned integer, and we'll go into the difference of signed versus unsigned integers later. The number of arguments, and then which is basically the size of the array that follows, and then the array of data that you've passed. This is roughly equivalent to whatever you typed in the console. So if you typed application name 1 space 2, then you're getting actually you're getting all of your arguments, and then you're getting your numbers at your arguments there. So the fun thing about this is that you can actually go in on Linux systems and change the very first argument in your application to give it a different name when you do a PSAUX or some other list of your process, as long as you don't go over the size of what you already have. You can change it, or at least you used to be able to back in the day, to give yourself a different name or whatever. This was actually used by a lot of bad applications, so I wouldn't be surprised if they didn't fix it. Anyway, the next line is the while loop. Basically what this does is it's going to go into use the getchar function, which is actually considered unsafe and insecure nowadays. It's something that we only normally see in tutorials and people just trying to learn, because there's actually better ways of doing this. There's also getc, where you pass it in the standard input stream, or there's other more secure functions. We're not going to go into those now. For today, getchar just simply gets one character and sets it to the C value that we've set, which is the integer. And then after it's been set, we compare the value of C to EOF, which in this case is end of file. Now, that value is a constant that's actually system dependent. On some systems, it's -1. On others, it could be some other value, which is why we've abstracted it out, and it's part of the standard input-output library to make it EOF, because it's universally understood that that is the end-of-file value. Now, some platforms have it a different value than others, which is why we have that. So don't be tempted to make it -1 or do something like that, because that's not platform safe. And the more comfortable you are with abstraction, the more portable your code will be and the safer it will be to run later on. So what we've done here is the while loop's run, it's checked. We are not at end of file yet, so we don't stop, which means we go into the inner loop, which is the if-else statement. The if statement says if C is equal to the character of tab, which is the T delimited, and then put char 92, put char 116. Now, this is something that will confuse a lot of people, especially if they're very new to programming. Back in the day, old farts like me had to remember what the numbers meant for every possible letter of the alphabet and key on the keyboard, because every key on your keyboard, if you look down, has obviously A, B, C, D, whatever, but what you may not know is that they each are assigned a numerical value as well, and that numerical value is both in decimal and hexadecimal. So in this case, the 92 is that backslash that's in front of the T in the tab that you're looking at there. And the 116 is actually the T. So that's what gets printed. It's printing two characters in this case, the backslash and the T. And because of that, we don't need to worry about messing with any string replacement methods or functions to change things in memory. We just blindly translate this letter to those two values, output them to the console, and because it's very general, and because in this case we're not using ANSI escape codes, which is another thing I asked him to look into, it'll just input that out when you're done. And if it's not equal to a T, then it'll just put whatever typed out. Now, in this case, this actually on my console over an SSH connection to my Linux box, which I actually was going to show until I realized the host name was in the output and you could all see it, it actually didn't do the conversion until after I pressed new line. So that could be a system thing because I was on SSH. I don't have a Linux box up at the moment locally to test this, but this was the best I could do in short notice using GCC in a CYGWin emulator that I couldn't get installed, so I had to actually go in and SSH to a Linux box, use GCC on that box, and run the app. So anyway, through this, the loop keeps going until finally the end of file, you press new line or whatever, and then the app returns cleanly with -0. Zero. And return 0, done. And honestly, if you press Control-C on your console, it'll do the same thing. So that's what's happening here. But there's a lot going on here because you realize that you're dealing with a console, which is actually a virtualized serial device, and you may have to worry about terminal settings. Also keep in mind that the int there is not an unsigned int. It means it's signed. What that means is that a signed int has the ability to be negative. An unsigned int can only be 0 or positive. In this case, essentially the int C is basically saying I have a bucket, and this is the type of things that that bucket can hold. In this case, I've defined a bucket that's very small. It can only handle a small integer, and because of the type of bucket that I've defined, I can actually only hold values over 2.1 billion or so, or under 2.1 billion on the positive range. So if you're doing a negative number, it's like -2.14783648 is like the smallest number it will hold, and then the largest number it will hold is actually that same value as a positive number -1. So it's like 2.14748 3647 as a number. If anything over that, it can't hold. It'll overflow, and that's another video. So I hope this helped. This does in fact compile. I tested it on a Linux box running actually on one of my production servers. It runs my website and everything, so it works fine. It does exactly what he wanted. But I would caution anybody looking at this to do a few things. One, look into why the getchar value func method is actually considered insecure and bad, and then educate yourself on the security implications of that. One thing you're going to want to do too is look up your ASCII table. That's the ASCII table, and that will show you all the values for all the different things you can print to the screen, both hexadecimal and decimal if it's a good one, and they're easily found on Google. The one thing too you want to think about is just go into your compiler and the thing that you're using. Try to find what the value for end of file is, the EOF there on that line, on the while line. I guarantee you it's probably statistically going to be -1, but some platforms are weird, so you never know. And it's always good to learn about these things. Anyway, I hope this works for you guys, and I hope it was educational.